Students, now we will discuss IIT problems on mechanics. Next problem is question number 4 about single pulley. Two masses M1 and M2, where M1 is greater than M2, are supported by a weightless string passing over a smooth pulley. Find number 1, the acceleration of the system. Number 2, tension in the string. Also find total load on the pulley. Now solution. We are given a smooth pulley and this is mass M1 attached with a string passing over a smooth pulley attached to other end attached to other mass M2, and M1 is greater than M2, mean M1 is heavier than M2. Now weight of mass M1 is equal to M1G, weight of mass M1 equal to M1G acting in the downward direction, and weight of mass M2 is equal to M2G acting in the downward direction, and tension is capital T acting in the upward direction, and on the pulley the tension is acting in the downward direction, same magnitude capital T. The direction of tension is always from the point where it is tied, away from the point where it is tied. Now let the acceleration of the system is small a. The mass M1 acceleration is in the downward direction, and for mass M2 the acceleration is in the upward direction, and tension in the string is capital T. As already told, free body diagram of mass M1 is, this is mass M1. In free body diagram we have to represent all the forces acting on the object. Now weight of the object M1 is acting in the downward direction and tension is acting in the upward direction. As M1G is more than capital T, therefore the acceleration of body will be in the downward direction A. Now according to Newton's second law of motion, the net force acting is equal to mass into acceleration. Net force is M1G minus T, as they are opposite in direction, and is equal to mass M1 into A acceleration. Let it be equation number 1. And free body diagram of mass M2 is, this is mass M2 and its weight is acting M2G in the downward direction and tension is in the upward direction. Now capital T tension is more than the weight M2G, so its acceleration will be in the upward direction of magnitude A. Again, according to Newton's second law of motion, we get T minus M2G is equal to M2A. Let it be equation number 2. Now solving equation 1 and 2, adding equation 1 and equation 2, so we get M1G minus capital T is equal to M1A. Second equation, capital T minus M2G is equal to M2A. Now add them. Minus capital T and plus capital T cancel each other, so we get M1G minus M2G is equal to M1A plus M2A, or you can write M1A plus M2A is equal to M1G minus M2G. Now in the left hand side we can take A common, and in the right hand side we can take small g common. Therefore, m1 plus m2 within the bracket into A is equal to m1 minus m2 into small g, acceleration due to gravity. Therefore, A is equal to m1 minus m2 upon m1 plus m2 into small g, acceleration due to gravity. That is, acceleration is equal to difference of masses upon sum of the masses into acceleration due to gravity. Let it be equation number 3. Now to find tension, from equation number 2, capital T minus M2G is equal to M2A. This is equation number 2. Now take M2G to the right hand side. Capital T is equal to M2A plus M2G. Now putting the value of A from equation number 3, so we get capital T is equal to M1 minus M2 upon M1 plus M2 into M2G from equation number 3, putting the value of A plus M2G. Now in the right hand side, M2G is common, so take M2G common, so we get capital T is equal to M1 minus M2 upon M1 plus M2 plus 1 within the bracket into M2G. Now within the bracket take LCM, so we get capital T is equal to LCM is M1 plus M2 and numerator become M1 minus M2 plus M1 plus M2 into M2G. Now minus M2 and plus M2 cancel each other. Therefore, we get capital T is equal to M1 plus M1 become 2M1, M1 plus M1 upon M1 plus M2 into M2G, or capital T is equal to 2M1 M2 upon M1 plus M2 into G, acceleration due to gravity. So this is the tension in this string. Hence, acceleration A is equal to m1 minus m2 upon m1 plus m2 into small g, acceleration due to gravity, and capital T tension is equal to 2m1 m2 upon m1 plus m2 into small g. Now to find load on the pulley, it is equal to, see in the diagram, it is equal to T plus T 2T. Putting the value of T we get is equal to 4m1 m2 upon m1 plus m2 into small g. This is the total load on the pulley. So this is the answer for single pulley system. Thank you very much.